So in this video, I'm going to do two more examples for applications of discrete random variables. Both of these involve insurance. The first one, let's consider auto insurance. And let's say that you are the head of an insurance agency and you're trying to decide how you should price an auto insurance policy. So this is going to be a one-year policy, and your target is for a male customer who's between 45 and 49. And so you've collected some data and considered some scenarios, and one of those scenarios is that for this customer, they may go an entire year and not have a single accident, in which case you as an insurance company would pay out $0. And the likelihood that that's going to happen for somebody, for this type of customer, maybe that's fairly likely. So maybe there's a 95% chance of that. So we'll say 0.95. So this is going to be the value for my random variable, and this is the probability. So maybe another possibility is that you could have a fairly minor accident, and let's say that the cost to the insurance company would be $5,000. And there's a 3% chance of this happening. Another possibility, maybe the person would total their car, and the insurance company would have to pay out $30,000, and maybe there's a 1.5% chance of that happening. And another possibility we'll say is that there's a big payout, but this is the least likely outcome, and that has a probability of 0.005. Now let's make sure this is valid. So I need to add these up and make sure that I get 1. So 95 plus 3 is 98, 99.5. Yep, that adds up to 1. So what, as an insurance company, if I sell lots of these policies, how much do I expect to pay out on average? So, for any one person, I might pay out nothing, or I could pay out $100,000. But if I sell a lot of these policies, what's the average payout if I split it between all the policyholders? So to find that, I need x times p of x. So 0 times anything is 0. That's easy. 3 times 5 is 15. Let's see, if I move this decimal over, that'd be 150. 15 times 3 is 45. Let's see, 1, 2, 3, move this decimal 3 places. 15 times 30, that's 450. Move this decimal 1, 2, 3 places. 5 times 100 is 500. And of course you can just use your calculator for this. But so I'm multiplying across to get the result in this column. Now I'm going to add those up. So 500 plus 450, that's 950. Plus 150, that's $1,100. So if I take all of my policyholders, average out all my payouts, then the average across the portfolio would be $1,100 per policyholder. Now, if I charge anything less than $1,100 per policyholder, I'm going to lose money overall. So in order to make some money, I would want to charge, at least $1,101, but probably something more like $1,200, and then I would average a profit of $100 per policyholder. Okay, so that's one example. So in another example, let's look at a life insurance policy. And so this is going to be a one-year term life insurance policy, and let's say it's a $100,000 policy, and for the person who buys this, let's say that there is a 0.9995% chance that there will be no payout. So that would mean the person lives, actually. So let's think about if we sell this policy for, let's say $200. Or let's say $240. So maybe it's $20 a month is what somebody pays for this. And let's think about what the possibilities are from the standpoint of the insurance company. So we're going to have our possibilities and our probabilities. Now, there are really just two scenarios here. The person lives or they die. So the probability that they live is 0.9995, and the alternative has a probability of 0.0005. Those have to add up to 1. Now, if the person lives, then I don't pay out any money, and as the insurance company, I have collected the $240 from the policyholder, and I don't pay out anything. So I'm up $240. Now, if I have to make a payout, the payout would be $100,000, but I've collected $240. So the payout would actually be $100,000 minus $240. So $99,760. But that's negative for me as an insurance company. So when I look at x times p of x, 240 times 0.9995, that's 239.88. And when I take negative 99,760 times 0.0005, this is negative 49.88. So when I add those two things together, I get a positive 190. So what this means is, if I'm able to sell lots and lots of these policies, and then take the average what I expect to make on average per policy, I will profit $190 if I'm able to sell them for $240. That's actually, I think, in real life, that would be a pretty high. So you could probably sell a policy like this for much more, as long as you sell it for more than $50. I think you'd be in good shape. Let me think about that for just a second. Let's say that you did sell it for $50, then we would be $50 here and $99,950, and so this has a probability of 0.9995. This is 0.0005. So when we multiply across 50 times 0.9995, that's 49,975. And when I take negative 99,950 times 0.0005, oops, I took one too many there. Delete. No, 0.0005. And that's 49,975. So if we, at $50, you're just going to break even. And so you want to charge at least $50. Well, $50 and a penny, I guess it would be exact. So, all right. So those are two examples of an application of discrete random variables in the field of insurance. All right. Thanks for joining. I'll see you next time.